Oh. I guess I'm live. Okay. That's 16 seconds. Okay. So this is just a test. This is the first time I'm streaming something. So it's going to be a test of my ability to live stream the topic that I'm going to do. So I decided to do some add math and continue a little bit of the add math lesson that I already had. So we're going to start with some of the questions that I left you off with in the last lesson, which was lesson 18. And the first question is to determine the nature. Determine, like this. Oops, here. Right, so we want to determine the nature of the roots for 2x squared minus 3x plus 1 equals 0. Right? And we're going to work on the solution. So I'm going to say given 2x squared minus 3x plus 1 equals 0, then if I use my quadratic formula, if I want to use my quadratic formula, then I notice that I will have a equal to 2, b equal to minus 3, and c equal to 1. And I can determine my nature of roots by just simply using the discriminant formula. The discriminant would therefore be d equal to b squared minus 4ac. Right? And that would mean that d would be equal to b is minus 3 squared minus 4 into 2 into 1. And this here is 9, this here is 8, and this is 1. So the discriminant that we have is 1. Since our discriminant is 1, discriminant I should say it like this: d is greater than 0, then you know what, I wrote that wrong. Right to the say. Since d is greater than 0, then we have two distinct real roots. Right, that is the solution to the first question. What? Let me just change this here. I'll just do this example 1. That's the first example that we did. And then going on to the next example, we're to find the value of k such that the equation has equal roots. And that equation is x squared minus 2x plus k equals 0. And we're going to see, let me change the color, since the equation has equal roots, then the discriminant d is 0. So we can see something like d is equal to b squared minus 4ac is also equal to 0. And from there, we can say from the equation, we know that a is equal to 1, b is equal to minus 2, and c is equal to k. So that means d would be equal to minus 2 squared minus 4 into 1 into k. And this is supposed to be equal to 0, right? Just because we follow the condition of equal roots. And solving that, I would get what, 4 minus 4k equals 0. So that means k is equal to 1. I should write it out properly. Minus 4 equal to 1. Hence, k is equal to 1. Right? So that's a solution for that one. Let's go to the next page. And let's work on example number 3. I think this is the last one that I gave you in the previous lesson. Let me check. Yeah, that's the last one I gave you in the previous lesson. Alright, so determine the values of k for which the equation has no real roots. And we're saying that x squared plus kx plus 9 is equal to 0. Alright, so if the equation has no real roots, then the discriminant is going to be less than 0. So I'm going to say here, I'll just change the color again. If the equation has no real roots, then the discriminant d is less than 0. So that is d less than 0. Okay, and if d is less than 0, then we have d equal to b squared minus 4ac being less than 0, right? And from the equation up here, so from the equation, we know that a is 1k9, a is equal to 1, b is equal to k, c is equal to 9. So we know that when we substitute here, we'll have k squared minus 4 is 1 and c is 9, and we're looking at less than 0. So k squared minus 36 is less than 0. Alright, this here you can see right away is like the difference of two squares. So using the difference of two squares, we can get that k minus 6 and k plus 6 must be times k plus 6 must be less than 0. Now, for this to happen, for this multiplied by this to be less than 0, it means that either this one here is less than 0 and this one is greater than, or this one is greater than and this one is less than, right? That's these two situations in which it could occur. So let's solve that. So either k minus 6 is less than 0 or k minus 6 is greater than 0. And the other scenario is that k plus 6 is greater than 0 or k plus 6 is less than 0. So this one here is one scenario situation, and this one here is another scenario situation. And from that, we can get that k is less than 6 or k is greater than negative 6, right? So that's the first one. or we can get k is greater than 6 and k is less than minus 6, right? So from there, we just simply draw a simple shape quadratic. This quadratic is positive, so that's a minimum curve. I'm just going to put this minimum curve right here, and I'm going to put here, which is minus 6, and then plus 6, which are the roots of the quadratic that we have. And we're looking at the situation of it being less than 0, so I'm looking at below the quadratic, and I can see right away that from this here, I don't even need to do this. As long as I find the roots of these two, as long as I find the roots, I would have been able to just draw this and get my solution. But I wanted to show you both ways. So you can see that you have one solution here and you have another solution here. And the one that matches from this one here, you can see the one that matches is going to be this one here. The k being greater than minus 6, which is this, and k being less than 6. So hence the equation has no real roots for the set of k such that it's it's greater than minus 6 but less than 6, right? And remember that k has to be a member of the set of real numbers. I think I leave a gap in the explanation here. Usually once you get these two here, right, once you get this and you get this, what you do is you just draw a number line. So let me just draw that number line so you can see it. I'll draw a number line right here. I'll put the minus 6 and I'll put the positive 6. And when we look at k greater than 6, sorry, k less than 6, we're going this way. And we look k greater than minus 6, we're going this way. And we see that the arrows overlap right here. So that's why we say that this is the solution. If you look at the other one, which is this one here, we can see that in this case, 6 would be over here, and then minus 6 would be over here. And if it's greater than 6, it means that they are going up in this direction. And we take all the solutions from this point going in this direction since it's less than minus 6. Notice there's no overlap. And since there's no overlap, there's no solution there. Right? So it's two things you can do. You can either solve this equal to 0, solve this equal to 0. Get your roots, minus 6. Draw the minimum curve that this here is telling you. And then you simply look for the region that they're interested in, less than 0, and you'd see below the quadratic, you'd see then that this is the solution, greater than negative 6, less than 6. If it is that you decide to go and list out all the case possibilities, which is this and this, then you solve for it and you have two inequalities for each answer. You just simply draw on a number line the inequalities, and the overlapping region is a part of the solution. Right? So that's it for that. I think I explained all that in the lesson as well. Alright, so let's move on from here. And we're going to start looking at today's topic. And I'm going to type in there. Today's topic is reducible. We change the color of it. Right? Reducible quadratic equations. Alright? And the objective for today's lesson, straight out of the syllabus again, objective is to solve equations in X reducible to a quadratic equation. Right? Now, this here is very simple to do. This lesson will be very quick. In fact, I'm going to give lots of examples, but it's just a matter of using your knowledge in algebra and rewriting the equation as you see fit to obtain something that looks like a quadratic, right? So when you're doing any kind of solutions in CSEC math, not every equation you meet is going to be written in a neat quadratic form. And the neat form is what you're used to. Many of them can be changed into that neat form. When that happens, this is why we call it a reducible quadratic equation. to make proper substitution that turns the original equation into a quadratic in a new variable, we need to do more problems. The more you solve, the more you'll be able to understand, right? I am trying to break it down into a few general forms for you that I've seen most of the time when you're doing CSEC math. So I'll do examples based on those general forms, right? And the solving of the quadratic equation is something you already know to do. You complete the square, use quadratic formula, use factorization, right? Once we go through all of this, you'll get to understand it better, right? Let's start off with examples. Oopsie. Right. Let's start off with example. We're going to start with example 1. Example 1. And we're going to solve x to the 4th power minus 7x squared plus 12 equal to 0. Now, this one here is basically even powers. Right? Let me just write that in properly. Even powers. Right? You're not going to get it working with odd powers unless you have something like x to the 6th and x to the 3rd. This one works well when you have mostly even powers. If you have a mix of even and odd powers, it could work too. But just know it's mostly even powers that you're going to find that they give you when you solve any problem. To begin by solving this, what you need to do is you need to rewrite this, and I'm going to just change. You need to rewrite this in a form that seems more like a squared plus b squared, ax squared plus bx plus c. And you can see right away that it has that form already. It already has that form. So you need to make a proper substitution to let that happen. So let me write out a solution for this one. So we're given x to the 4th minus 7x squared plus 12 equals 0. Right? That's what we're given. And if we you know what? Let me rewrite it first so I can show you what I'm talking about. If we're going to rewrite this, right, I can see that this x squared in the first part over here can be written like this. And I'm seeing that this here can be a factor here. So if I decide, I can say let x, and I'm going to use a capital X here, let x equal to x squared. Right? If I'm going to let x equal to x squared, then the given equation becomes x to the 2nd power minus 7x plus 12 equals 0. Now, sometimes people don't like to use the capital letters instead. You can use something like y, you can use something like z, you can use any other variable that you want, but you can't use the same variable. I like to just capitalize the variable that is inside of here. So whatever this variable is inside of here, I just like to capitalize it. So I tend to do this instead of using y. Alright? Then given the equation becomes this, right? We would use our common methods that we already know how to solve. So we can use, and I'm writing this in a different color because I'm just going to write the methods here, using factorization, right? Or using completing the square, or using quadratic formula, we can solve this equation and we'll get I think 4 by 3, and I can say -4, -3. If I add those two together, I'll get x minus 4, x minus 3, positive 12. Yeah, right. So we'll get that x is equal to 4, or x is equal to 3 when we work that out and solve it. I chose a simple one just to be able to do this here. Right, so we'll get that. And now we have to remember we made a substitution in the beginning. We made a substitution here. So we can say something like since x, let me write that over here, x is equal to x squared, then x squared is equal to 4, or x squared is equal to 3. Now, I chose x squared to be the first one to deal with because I want you to understand that as you reach this point, you should be able to solve this type of equation already. Right? This type of equation should be easy for you to solve already. So I'm just going to solve this one. The rest of them, I am not going to go through the solution of them, right? Because some of them requires that you learn topics that we have not reached yet. But I want you to just simply understand that what we're doing is we're taking the quadratic that they give us, using a reasonable substitution to get it in the form of a quadratic, using the methods that we know to solve quadratics, get a value for this new variable that you introduce, reverse the substitution that you do, and then you'll get this point here. At this point here, you just simply solve using whatever methods you need to solve this. Right? And in this case, we will tend to say that x would be equal to plus or minus the root of 4, or x would be equal to plus or minus the root of 3. Right? And that means that your x would be equal to plus or minus 2, or your x would be equal to plus or minus root 3. Now this works out correctly because if you notice, you have power of 4. Power of 4 meaning that you should have at least 4 roots inside of there. 1, 2, 3, 4. Alright? So this is just one of the forms that it can come in. You can get these even powers that you just simply do the substitution for, and you'll be able to get a nice quadratic. I'll do a couple more of these so that you can see where they are. The next one that you can get, and I'll just call this example 2, is something like this. Solve 3 over x plus 2 over x squared equal to 1. Right, equal to 1. Right? This one I would call a fraction form. This one I would call a fractional form because you're dealing with fractions. And what you have to do is you have to get rid of these denominators here. Right? You have to get rid of these denominators here. You take the highest order at the bottom, which is this x squared here, and you multiply everything by it. So if I take this and I multiply by x squared, and I take this and multiply by x squared, and I take this and I multiply by x squared, I should be able to get rid of everything at the bottom. Right? So let me just write the solution. So given 3 over x plus 2 over x squared equal 1, we multiply throughout by the highest denominator. You could say highest order denominator if you wish. Right? So we do the highest denominator, and with that we'll have something like 3 over x, I'm just going to put this here, times x squared, and let me just put this like x squared, and then times x squared, right? And plus 1, right? This here would cancel off, leaving 1 power here. This here would cancel off, leaving nothing, and this here would be what you multiply by. And you would end up with 3x plus 2 equal to x squared, and rearranging it, you would be able to get x squared minus 3x plus 2, sorry, minus 2 equals 0. Right? Notice now we're able to take this fractional form and get to this form. Now it might be such a situation that you would have to do a substitution, like I don't really think it's necessary, but you could probably try doing a substitution like 1 over x squared, right? Sorry, 1 over x as a substitution. So if you did that, you'll have 3, you'll have plus 2 into 1 over x squared, which is just simply 1 over x to the second power, because 1 squared is 1, x squared is that, and then equal to 1, right? And you can just replace this with an x, this with an x, so you'll get something like 2x squared plus 3x minus 1 equal to 0. This here should work out as well, right? This here should work out as well, and when you reach the end, you just reverse that substitution. I prefer to do this because I'll get rid of my denominators easily, right? I prefer to do it that way. Don't think that you can't do a substitution. You could do a substitution, right? All right, so once you reach here, you solve this, and I think your calculator should be able to give you yeah, equation, let's see, 2, a 3-value equation, I think that's 1. All right, so let's see. We have a as being equal to, see, I don't realize this is cutting, right? Let's see, a as being equal to 1 minus 3 minus 2, right? Let's see, 1 minus 3 minus 2, and I don't have a d. Oh, I was supposed to put d as 0. Nope, 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 this is 0, 1. Let me see. Complex, modulus, nope. Two value, quadratic, oh yeah, it's 2. Right? So we have a as being equal to 1 minus 3 minus 2. So 1 minus 3 minus 2. And you get 3.56 and negative 0.56. So 3.56 and negative 0.56. So right away you get x is equal to that. You can check this one as well. Now, I just want to say, don't do a calculator to solve. Use a calculator to verify. Reason is, this is better off written. These answers are better off written in surd form. So to get this into surd form, you'd use quadratic formula, and I'll just do it very scrap right now, right? So I'll just do it very scrap. This is not a proper solution. So I'll have my a as 1 minus 3 minus 2, and I will end up with x is equal to minus b, so it's minus of minus 3 plus or minus the square root of b squared, which is minus 3 squared, minus 4 into a into c, and then all over 2a. Right, this works out to be x is equal to 3 plus or minus, this is 9, this is 8 plus 8, so that's 17, all over 2. And this is your answer here. Because you're learning surds, it's better to leave your answer in surd form rather than putting it in a decimal form, right? So don't think that, you know, these questions are difficult to solve. It's not difficult. You just have to rewrite it in a form for quadratics as you need to, right? The next form that we're going to look at is something like this, example 3, and I'll call this 2x minus 5 into 2 to the power of x plus 6 is equal to 0. And with that, I say that this one here is best to call it, what should I call it? I should call it exponential form. Right? And given 2 to the power of 2x minus 5 into 2 to the power of x plus 6 equals 0. All we have to do now is rewrite this in the form. So we can say that this here can be written as something like 2 to the power of x squared minus 5 2 to the power of x plus 6 equals 0. We can say something like let x equal 2 to the power of x. Then the equation becomes x squared minus 5x plus 6 equals 0. And you simply solve that as well. Once you finish solving that, you will have two answers. And let me just see if the calculator can do that as well. We're looking at 1 minus 1 and 6. Let's see, 1 minus 1 and 6. And we get 0.5, which is a half and a half. Okay, so we get a positive a half, but we get a half and a half. Is that correct? That doesn't look correct. You see? So a half, 1 minus 1, 6. That's 1. A half, and a half. Same value. Okay. So you get a half, so you'll get at the end of it that 2 to the power of x is equal to a half, and 2 to the power of x is equal to a half. Alright? And you just simply need to solve that. I'm seriously doubting this here. I think maybe that is something else. Maybe. Right? So you can try and see if you can get this. I think factorization would allow me to do this, 1 times 6, 2 times 3 minus 2 minus 3. Yeah, so let's see. So yeah, I'm supposed to get 2 and 3. How did I get that? Yeah. So you would have here that x would be equal to 2, or x would be equal to 3, right? 2, 3. So that means that 2 to the power of x is equal to 2, and 2 to the power of x is equal to 3. Good? Now, to solve this, you would need to learn logs, which you didn't do yet, and you'll learn that in a later lesson. So we'll stop right there for now for that. And then next form that you can get, I think this is the fourth equation, yeah, fourth example, yeah. Example 4. Right? Example 4, we can solve for theta between 0 degrees and 360 degrees. Right? So we can solve something like 4 sine squared theta minus 3 sine theta minus 1 is equal to 0. We can solve something like that as well. So if you're given the equation, 4 sine squared theta minus 3 sine theta minus 1 equals 0. We can rewrite it in a form like this. We can say 4 into sine theta squared minus 3 sine theta, and then minus 1 equals 0. So that means we can do a substitution. We can say, well, I'm not going to use that. I'm going to use y. So I'm going to say let y equal to sine theta. So that means that I will get 4y squared minus 3y minus 1 is equal to 0. And I can solve that, and at the end of it, I'm just going to put a and b. At the end of it, we can get something like sine theta is equal to a, and then sine theta is equal to b. Right? So we can solve that and get something like this. A and b is just some value or answer that results from this. Once we reach there, we can use our knowledge of trigonometry to solve these sine problems, which you will do in trigonometry much later on in the series. The next one, let's look at example 5. Did I label that other one? Oh, yeah, we'll call this one trig form. Right? We'll call that trig form. It's short for trigonometry, which you all should be familiar with. And then next one that you can come across, solve x minus 2 root x plus 1 equals 0 for x greater than or equal to 0, right? This one is a square root form. Just write that out. Square root form. Right? This one is a square root form. And it's easy to rewrite this as well, as long as you get a little bit of practice and you do some indices. We can say given x minus 2 root x plus 1 equals 0, that let the x equal to the root of x, because you note this one is just simply root of x squared, and we already have the root of x here. So this is another way to write these. So we can just simply say that we have x squared minus 2x plus 1 equals 0. Again, we solve that. Once we solve that, remember at the end of it, we'll get that root of x. Once we reverse the substitution, root of x is equal to something, root of x is equal to something, and we'll just square both sides, right? So we'll just say x would be equal to a squared, whatever a worked out to be, and x would be b squared, whatever b worked out to be, right? I think with this one, it's probably 1 for the solution. X is equal to 1, right? So that is how you go about solving equations that don't look like quadratic equations. You should just try and find a reasonable substitution, substitute it, and then use your methods that you know, reverse the substitution, and then once you reverse the substitution, you just solve that equation that you get, well, those pair of equations that you get. I am not going to give you an exercise to solve quadratic equations because some of these forms here you are not familiar with yet. All I want you to do, however, is be able to write these weird looking equations that could come in any form into a quadratic form, right? So this is the exercise that I'm going to give you. So the exercise is for each equation below, reduce it to quadratic form, right? Reducing it to quadratic form, and these are the equations that we're going to work with. So x to the 4th power plus 7 equals 6x squared. Then we have 5 over x is equal to 2 minus 4 over x squared. 3x squared plus 7 equal to 10 into 3 to the power of x. And 4, we have root of x plus 3 equal x. I go on for that. See 5. We get 2 cos squared theta equal to 5 cos theta is 2 and 6. So we have x 6 power plus 4 or 5 x to the 3rd 7. We have 2 over x plus 7 equals 3 over x squared. And see, it's the end of the page, so let me just put it here. We have 4x plus 1 minus 20x 4 to the power of x equals that. I don't want to get on the page, so let me just put number 9 here. I'll put it in a different color so don't get mixed up. Number 9 and root of x plus 5 equal to 2x, and then number 10 be 3 sine squared x plus sine x. Right? That should be easy for you to do. It shouldn't be too much of a problem. When I do the solutions to this in the next lesson, I would just be writing this, and I'll be writing the quadratic form. I'm not going to go through how I converted each of them. If it is that you have a question on how I converted each of them, you can let me know, and that will be it. All right? Okay, so that's it. This is, as I said, a test for the first lesson I am streaming. I am going to try and stream more regularly for the lessons for AdMaths, and I will see you in the next lesson.